Hey guys, this is Mr. Martinez. This week we're going to be going over a couple of different kinds of conic sections. There are four kinds of conic sections: the circle, ellipse, parabola, and hyperbola. Um, and of course, conic, if you're unfamiliar, refers to cone-like. Circles and ellipses are similar in the sense that a circle is, a perfectly round circle. A ellipse is an oval, basically. A parabola, you've seen these, the um, U-shaped function. Hyperbola is essentially having two of these, but their appearance they occur in different times based on the equation. An ellipse in standard form has this form: x minus h quantity squared over a squared plus y minus k quantity squared over b squared equal to 1. You can see here, equation-wise, how ellipses and circles are similar. If this were a circle, these are not divided by different numbers. That's what the a squared and b squared are. These are different numbers, and ellipses are equal to 1, whereas a circle would have been x minus h quantity squared plus y minus k quantity squared equal to the radius squared. Okay, the ellipse is going to look different depending on what is bigger, the a or the b. Okay, if you have this ellipse and let's say that your a is bigger than your b, then this means that your ellipse is going to be it's going to be longer, going from left to right. Okay, ellipses have two vertices, one way out here. I'll say V1 for vertex 1, and vertex 2 is going to be way out here. You actually have 2 points inside here called foci, or they're like two focuses, and then the plural of that foci. We are not going to be finding that. Now the point that's right here in between, right in the middle of this ellipse, is called the center, and the center can be found using the h and k, just like with a circle, and just like when you're finding the vertex of a parabola, it's just going to be h and k, and that comes from the equation. Now, the other thing we need to know about this, if you had a line that connects the vertices right here, that goes through the center, this would go through the center, that is called the major axis. Major axis. Okay, and the major axis is just going to basically be 2 times your a. Likewise, if this were an ellipse that is taller than it is long, like it is here, the same deal. You have a center in the middle. I'm just going to put a little C there. You would have 2 foci right here. Again, we're not going to concentrate on that. You have 2 vertices. So let's say V1 and V2. The same deal if you had a line that connects this right here. That would be called the major axis. The length of that, in this case, would be 2b. Okay, because it's taller than it is long. Okay, if this were this way, if you had this point right above here, so in other words, this is your center, and if you went up in this case, because this was longer this way, so in other words, this is A and that's A, so get it this way, your major axis is 2A. From your center up to this right here, this would be your B, and you would have a length of B here as well. Your minor axis, in this case, is 2B. If this were taller like this, the same deal, where this is, in this case, B and B, because in this scenario B is bigger than A. Your major axis is 2B. Your minor axis, in this case, is 2A, because this would have been, you're going A this way and A that way, so that would be 2A. Okay, think about it more as your center is HK, and whichever way your your A is whatever's under the X. X goes left to right. Y goes up and down. That's why that appears like that. But the key thing is here, your major axis is twice however long that you're doing it here, or twice however long that it is tall. Your minor axis is the smaller one in there. Okay, in this example, we have the equation x minus 3 quantity squared over 4 plus y plus 2 quantity squared over 9 equal to 1. So here I can see that our h is 3. Remember, h is what's being subtracted from your x. So here I'm going to say that my h is 3. In this case, because this is a plus, because it has to be subtracted, you're saying y minus negative 2. That's why your k is negative 2. Kind of just train yourself. Whatever you see here, it's going to be the opposite. So if you see minus 3, your h is positive. If you see plus, then that means that that's going to be negative. Once we have our h and our k, we know that our center is going to be the point 3, comma, negative 2. Okay, so from here we have our center, 3, negative 2. What is under the x's here is the 4. So we're going to say that our a squared is 4. The square root of both sides, a equals 2. So in other words, from your center, you're going to be going up and down. You're going to be going right and left too, sorry. Go 2 this way, and you go 2 the other way. Your center here being in the middle. Over here, this is under this 9 is under these y's over here. So I'm going to say that b squared is equal to 9. Square root of both sides, you're going to get b equals 3. So in other words, from my center, I'm going to be going up 3 and down 3. So if we were going to graph this, which you're not going to have to do, but you should still see how this is graphed. Our center here, remember our center is at 3, negative 2, so we go over here to 3, negative 2. All we'd have to do is I'm going to put my point there, and here I'm going right and left 2. So if I go 2 to the left, 2 to the right, and then I'm going up and down 3. So if I were to go 1, 2, 3, up, I'd be there. If I go down 1, 2, 3, this is not a perfect graph, but let's just go with it. Okay, and you would just connect the dots. Okay, now because this is longer going up, that's where your vertices are. So you can have vertex 1 versus vertex 2. This is a terrible looking ellipse, but you know, imagine it was a perfect oval. Okay, now this is going to be your major axis is going to be the length here, which because this was B and B, it's going to be 2 of these. So I'm going to say my major axis is going to be 6 because that's just 2 times the 3. My minor axis, in this case, because this is the short side, it's going to be 2 times that. So my minor axis here is going to be 4. Alright, so this looks very similar to when we were talking about an ellipse. The key thing here is that you're subtracting. You're adding these both together when it's an ellipse. You're subtracting when it's a hyperbola. And then it does matter what goes first, like what's bigger, the A or the B. Okay, so you determine the center the exact same way, but this is going to look different. So just for example, let's say your center is whatever this is here. And let's say that, remember, this is underneath your x, and this is x minus y. So that means that this is going to look like 2 parabolas opening to the sides. You know that because the x is first. If this is x squared minus y squared, it's going to look like so. So first of all, so this would be, you're going this way A, you're going this way B, B. You're going that way A and A, you're going up and down B. This would basically create like a little box. Okay. these points out here, because this is x minus y, this is where your vertices are going to be. So I'll say v1 and v2. Okay, and then this is going to end up looking like this. It'd be like having a sideways parabola opening to the left and the right. Okay, and like I said, you know this because it's x squared minus the y squared. If this were, let's say, the situation where you had y minus k squared over, I'll say, b squared minus x minus h quantity squared over a squared equal to 1. So what's different here is that your center is still going to be hk. That's not different. Now this is underneath the y. This is y squared minus x squared. So this is going to actually open. It's going to be a hyperbola like this, but it's going to open up and down. So let's say that our center was, give ourselves some room here. Let's say your center is that. This is underneath the y. So here I'm going to go b up and down. And then we're going to go a left and right. I know that because x goes left and right. This actually didn't have any, does not have any arrows. I don't have to worry about that. So this would be going like this. Remember, y squared minus the x squared. So our vertices are actually going to be here and here. So this is going to look like you have two different parabolas opening up and down. Okay, this would be called a horizontal hyperbola. This would be called a vertical hyperbola. In your exercises, essentially, this is all you're going to have to do. You're going to have to determine what's the center, which you should be able to take from the equation, and what are the vertices. Remember, depending on whether it opens up or down. And when you're talking about the ellipse, you're going to be responsible for determining the center and the length of the major and minor axes. So remember, if this is underneath your x, that's how much you're going left and right. And whichever one, this depends on whatever's bigger, that's what determines if this is going to be sideways or horizontal ellipse or an up and down ellipse. Because it's taller going this way, you would know that because what's underneath the y is bigger. So it depends which one of the numbers underneath this is bigger. Bigger underneath the x, then it's going to be longer. If it's bigger underneath the y, then it's going to be taller. And whichever the length of the, like in this case, this example was a vertical ellipse. So in this case, it's going to be 2b. Our minor was 2a. And if it were sideways, that would be reversed. All right, I hope this helps. If you have any questions, make sure you shoot me an email or join one of these Zoom sessions during the week.